Alright, so now we're going to take those trig ratios and we're going to take them in a different direction just to apply it a little bit more. And so your next topic is angles of elevation and depression. The learning target is I can solve problems involving angles of elevation and angles of depression. So first thing we're going to do is define a couple, or the angle of elevation, angle of depression. Angle of elevation, we can use this little picture over here on this side, is the angle that is made from the horizontal line of wherever we're talking about, to the point that they are looking up. When we are looking up, okay, so up is that first blank. So the horizontal line, if you're looking up, that is the angle of elevation. Angle of depression, on the contrary, is the angle that is made from the horizontal to the point when looking down. Okay? So the horizontal looking down, that is the angle of depression. So like I said, these problems are like the trig functions, the trig ratios that we build in order to solve problems. We just apply it a little bit more in this section. To real life examples. So when we are given a problem, we will usually be given two of the following three pieces of information needed in order to set up the problem. First thing is we might be given how far away from an object the viewer is. We might give what the altitude is from the ground to the object. Or we might be given what the angle of elevation or depression is. Okay, so in order to solve problems like these, the first thing that we're going to want to do is draw a picture of the situation. Every single time, draw a picture of the situation so we can kind of view it visually. Second thing you're going to want to do is you're going to want to label all of the information on the picture, all being that blank right there. We need to know every single piece of information. When I say all of the information, I'm talking about opposite, adjacent, hypotenuse, the angles, all of the dimensions as far as how far something is from somebody else. All of those things we need to know in order to solve this, in order to solve and label all of the information. And then lastly, determine based on the angle and sides that have been labeled which trig ratio we can use, and then of course solve. So example 1 just helps us get used to an idea of looking at what is an angle of elevation, what is an angle of depression. And we see this first one, angle 1, the horizontal line is through here, and 1 is the angle in between the horizontal line and the line created. And we see it's going downhill to that person right here. So what that's going to be is an angle of depression. Angle 1 is an angle of depression. Angle 4 from the horizontal, it's the base of the tree looking up at the person's eyes. It's going up to that person, which means this is angle 4 is an angle of elevation. And we don't need to write these two down, but we can see angle 2 would be an angle of elevation, and angle 3 would be an angle of depression. If you're looking up to the top of the tree, it's an angle of elevation. If you're looking down to the bottom of the tree, it is an angle of depression. So example 2 says that the Seattle Space Needle casts a shadow, a 67-meter shadow. If the angle of elevation for the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? And we need to round to the nearest meter. Alright, so the first thing we're going to want to do is draw a picture. So I'm going to go ahead and, remember I'm a terrible drawer, so I'm going to draw a little Space Needle here, and it's going to go down to the ground here. Something like that. You guys could probably draw a much better picture. And it says that we're given that the shadow, there's some shadow here, so let's go ahead and draw the other part of this Space Needle here. This is the shadow on the ground here. The shadow is 67 meters. 67 meters. And it says then that the angle of elevation from the tip of the shadow, that's this point over here, the tip of the shadow, all the way up to the top of the Space Needle, all the way up here, is 70 degrees. And we want to know how tall, and I'm going to label that H this time, how tall is the Space Needle, and we're going to round to the nearest meter. Okay, so then that second part right there, it says to label all of the information on the picture. And so let's go ahead and label what the hypotenuse is, what the opposite is, what the adjacent is. Remember, the hypotenuse is always the easiest one to see because that's formed across from the right angle. And our right angle is going to be right here. So this has to be our hypotenuse. And I'm going to do HYP just to make sure that we're not confused with H and the hypotenuse. The next easiest one is take your angle that you're at, and the one across from the angle that we know, that's going to be our opposite. The one opposite the angle we know is the opposite. And finally, this last angle, the one that's, or this last line side that's lying next to the angle, that's going to be our adjacent. Okay, so we can see we're trying to find H, and we know the shadow, the 67 meters. So we have opposite and adjacent, and we know that the tangent is the one that will help us with opposite and adjacent. So the tangent of 70 degrees is going to be equal to our opposite, which is H, over our adjacent, which is 67. Okay, now this is just solving. We have to solve for the height. So we're going to multiply by 67 on both sides, because if we do that, we get our 67s to cancel out. And we're going to be left with 67 times the tangent of 70 is equal to H. Okay, then all we have to do from here is actually solve this problem using our calculator. So we're going to get out our friend, and we say, hi friend, type in 67 times the tangent of 70 degrees, press enter, and we get 184.08. Remember, we're rounding to the nearest meter, so that would be rounded to 184. So 184 meters is the height of our Space Needle. Alright, example 3. It says an ice climber stands at the edge of a crevasse that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees, and we want to know how deep is the crevice at this point, and round to the nearest foot. Okay, so I'm going to just draw a triangle this time. We've got 115 wide, and that is the width of our crevice, 115 feet. And we know there's an angle of depression that's made. It's from the edge of where she stands, so she's going to be somewhere over here, right? Woo, she's standing all the way down to this point over here, to the bottom of the opposite side. So that's 52 degrees. And so let's connect this triangle here. We know this is going to be our right angle. And we want to know how deep is the crevice at this point. So how deep is this part right here, the crevice? So this is what we're trying to find, and I'm going to label it D for deep. How deep is the crevice at that point? And so we can see we've got to first label all of our sides as opposite, hypotenuse, and adjacent. We know the one across from the right angle is going to be our hypotenuse. The one across from the angle that we know is our opposite. And so that leaves this side right here, our adjacent. And so again, we're faced with an opposite over adjacent. So we're going to be using tangent of 52 degrees this time is equal to our opposite, which is D. We don't know it, so it's D, divided by 115 feet. Now we just have to solve for D. So we do that like we have been doing a lot. Multiply by 115 on both sides, because the 115s will cancel out, and I'll be left with 115 times the tangent of 52 is equal to our depth, how deep the crevice is. Okay, and then finally it's just punching those numbers into our calculator. So we got to get our friend back out, and we're going to type in 115 times the tangent of 52, and we get 147.1, which rounds down to just 147 feet. And that is how deep